So now let's spend some time talking about the scientific method. The scientific method is a set of rules, procedures, and assumptions that enable us to make sense of our observations. So what I want you to think about is the scientific method tries to combine the logic and reasoning from rationalism with the ability to observe things from empiricism in order to try to observe phenomenon and understand our world. So we develop a theory or we develop hypotheses based upon logic or reasoning, things that we think make sense to us given what we understand, and then we systematically collect data to test that theory or that hypothesis. That's where the empiricism part comes in. So we don't simply just come up with an idea based upon logic and reasoning. We then go out and test that idea to see if the data supports our ideas or not, our theories or our hypotheses. And if it does, that provides evidence in support of our theory or our hypothesis. If it doesn't, then that tells us that our hypothesis or our theory might be incorrect. But we always have to use the data to determine whether or not our theory or our hypothesis that we derived is an accurate one or not. So I'm going to take a few minutes to talk about the four canons of the scientific method. So the four kind of key components, principles of the scientific method. The first is systematic empiricism, right? So we know what empiricism is now, right? So it's acquiring knowledge through observation. Systematic empiricism is having a systematic, structured way of collecting our data. So if we're going to ask people questions, we ask everyone the exact same question the exact same way. If we're going to measure a variable, we measure it the exact same way each time. So it's a very structured way in which we collect our data. And you'll see from all the different research methods that we're going to talk about in class, there's a structured way in which the data is collected and it's organized. So this is a key component of the scientific method, is being able to systematically make your observations. The second is determinism. And that's the assumption that anything that we're measuring, any kind of human behavior, any phenomenon, has identifiable causes. It could be one cause, it could be multiple causes, but the idea here is that there is an identifiable cause. So the idea of cause and effect, right? We may not know what the effect is, what the cause is, but we know that one exists. And if we look hard enough, we'll find it, right? So the idea being, if you have a hard time falling asleep, there's a reason why you can't fall asleep. It's not happenstance. There's something that's going on that could explain why you're unable to go to sleep, right? It's like there's a reason why people are prejudiced. It's not just because they were born that way. There's some reason behind it, and it could be multiple reasons, but there's a reasoning behind why people are prejudiced. There's a cause that we can identify that would explain why people are more prejudiced than others. The next is parsimony, also oftentimes called Occam's razor. And that's the assumption that the simplest explanation of a phenomenon is the most likely to be correct. So if you have two equally compelling theories that try to explain a phenomenon, you want to go with the simplest first and test that particular theory before trying to use a more complicated explanation to test that theory. So the goal here is to start simple with your theories and only add complexity when needed. It makes it easier to test your ideas, and it makes sure that you're not adding concepts or information that's not necessary. You only want to include in your theory the things that are essential, that are required for the phenomenon to be evaluated. So in other words, you don't want to add anything extra. And then the last one is testability, right? Make sure that we have questions that we can solve empirically, right? So things that we can observe. So the scientific method only tries to answer questions that you can observe and provide evidence for through systematic observation, right? So if you cannot find some way of using empiricism to be able to observe your phenomenon and test the phenomenon, it's not a scientific question, right? So it might be an interesting question, but it wouldn't be one that scientists would explore because there's no way to systematically observe whether or not your theory or your hypothesis is accurate. So let's do a quick test to see if you can identify questions that are testable versus questions that are not, right? So the first one, are people born inherently good or inherently evil? If you think about it, this is probably a question that would be difficult to observe, because how do you know if someone's inherently good or not? That means that they were born that way. And how do you observe something that happens before birth? And how do you observe if they're evil or good? So that would be a question that people would try to test empirically or use a scientific method to test. So that would definitely be a no. Will drinking caffeine make people anxious? Now, I can definitely devise a study that would test this idea, right? I can give some people caffeine, other people decaf, and then have some way of measuring anxiety. Either it could be, measuring their cortisol levels or having them report how anxious they feel, right? That would be a way that we could observe the effects of caffeine on anxiety. So that's definitely a scientific question, a testable question. What is the meaning of life? That might be a philosophical question, but that's not one that you can actually test. So that wouldn't be a scientific question. How does the presence of others affect a person's behavior? That is definitely a testable question. The whole field of social psychology looks at the impact of others or their environment and how that impacts their behavior. So that's definitely a testable question. All right, so let's go back to our thought questions really quickly from the beginning of the class. The first one was, if we want to deter crime, should we increase the length of prison sentence times? And based upon data that's been collected, they found that no, that's not a good way of deterring crime, because people don't look far enough into the future to think about the consequences of their actions. And also, people tend to think that they're going to get away with the crime, right? So they think they're going to get away with it, so it doesn't really matter what the punishment is, I'm not going to get caught anyway. So that's not an effective way of deterring crime. And the second one, if we want to get people to vote more, should we highlight that low turnout is a big problem in elections? The answer again is no. There's data that shows that what you should do is the exact opposite. You should tell them that everybody's voting, because voting is a very social process. And if you're a Democrat and you say all Democrats are voting, you want to be a good Democrat, so you want to go and vote then. Or if you're all Republicans are voting and you want to be a good Republican, then you're going to want to go vote too, because you want to show that you're a good Republican. So the key is to tell the opposite of what they're suggesting and say that everybody is voting in your group, and therefore people would be more inclined to actually vote. But the reason we know the answers to these questions is because someone has used a scientific method to test these ideas and to come up with a more conclusive answer. All right, so a couple things I want you to remember from this lecture. Definitely know the ways of acquiring knowledge. Know why the scientific method is the best way of acquiring knowledge. And know the 4 basic canons of the scientific method. So when you're reviewing, definitely focus on these particular things as you review this particular lecture today. And then read chapter 2 for next time.